In this lecture, we'll look at the relational algebra representation of group by and having. The group by operation is represented in RA by the gamma operator for group. This operator takes a relation as an argument and produces a new relation with tuples grouped into aggregate tuples following rules that are just like those for the sequel group by. The gamma or group by operator takes two kinds of subscripts. First, it takes one or more grouping attributes, so gamma flavor or gamma first name, last name. And these are analogous to the grouping columns in the sequel group by clause. And we can also add optional additional subscripts giving aggregate operations and names for each aggregated result, marked with an arrow. For instance, we can write gamma of flavor and then average price, in the next line here, arrow A price. These are analogous to aggregate functions in the sequel select clause, but with required column renaming. So for instance, this query, select product ID, min score, low, max score, high from rating group by product ID, translates out as gamma of product ID and min score renamed as low and max score renamed as high on rating. There are several points worth noting about that RA expression. First, function calls, like max score, for instance, there, are not allowed as names of attributes under RA, even though SQL will permit them as column names. So the aggregate results must be given attribute names via the arrow syntax. It's not optional. And second, the attributes of the resultant relation are exactly the grouping attributes and any additional aggregate attributes. There is no way for the RA notation to even express the idea of including non-grouping attributes in the grouped relation. For that matter, there's not even a way to express omitting any of the grouping attributes from the gamma result. In effect, gamma says that if it's in the group by, it's automatically in the select clause and vice versa. And then third, the gamma operation is effectively also a projection, since its subscripts determine exactly which attributes will be included in the grouped relation. There's no need for a pi operation in this example, even though there would be a select in the equivalent sequel. So question 1. What if the sequel had been select min score, low, max score, high from rating group by product ID? This omits product ID from the result. How do you think we would express that in RA, given the bit about gamma not letting you drop any of the grouping attributes from its result? The answer then is that in that case we would need, in fact, a pi operation. We would have to apply pi or projection low high on the result of the gamma operation to trim out that product ID. Now interestingly, we need no special RA operation for the having clause. The existing select operation serves both for where and for having operations. If you apply select before applying gamma, then it acts as a where filter. And if you apply it after the gamma, then it acts as a having filter. Recall that the only difference between having and where was simply the order in which they were applied relative to the group by. SQL syntax needs a means of designating one clause to apply before the group by and another to apply after. RA doesn't have that problem. You can specify any order of operations just by correctly parenthesizing and nesting sub-expressions. So, question 2, with all that in mind, rewrite the following sequel in RA. And a reasonable answer would be, we're going to do a gamma or group by on flavor and an average price renamed as A. And then that'll be on product. And then the result of that, we'll do a select and require that A be less than 10. Now, did you remember that average price can't be used as an attribute name? You have to use the mandatory aggregate rename in the select subscript, the A that we used in this example answer. Okay, so now try this one instead. It has both a where and a having clause. Take into account what we just said regarding the order of action of where and having. So a good answer for this one might be something like this. So in the following order, kind of inside out, this expression does the two joins, and then a sigma for the where clause, where flavor equals chocolate. And then on that it does a grouping by customer ID and a selection, and also computes the sum of prices. And then finally a selection on the result of that grouping that requires the price be greater than, or the sum be greater than 10, and that's the halving clause. And then at the very end, a projection to give just the sum as the result. Now, if you included a row operation, by the way, be sure you understand that a row or a rename was not needed, because the rename of some price as A is sort of a free side effect of the gamma operation. Indeed, as we said earlier, it's really a required side effect. You have to include that rename and use it in the subscript of the outer sigma, even if the original SQL didn't. And be sure you understand why there is a final projection or pi operation, the pi of S up there. The SQL doesn't select customer ID itself despite grouping on it. But the gamma operator can't help including customer ID. It cannot exclude its own grouping columns from the attributes it produces. So an additional projection is needed in this case, as discussed earlier. And we're getting fairly deep into RA now, so in case you didn't get the answers perfect in the prior questions, or even if you did, let's do one final example before moving on. Especially if you didn't get the earlier ones perfect. Spend some time on this one, reviewing all the prior examples, and see if you can get an exact answer. There's also a new challenge in this question in that you're asked to return some non-grouping columns, MySQL style. If you need to, review the discussion in an earlier segment regarding how to get non-grouping columns in Oracle. You'll do something similar here. So with all that, translate this SQL into relational algebra. And it's okay if the RA relabels sum of units, even if the SQL does not. You should get a SQL statement with one natural join, 4 standard joins, one rename, one grouping, 2 selections, and a projection. So after what may have been some thought there, here is a reasonable answer. And let's go over that sort of point by point, since there are several points of note in that answer, and this is an opportunity for a bit of review. First of all, we used a natural join between person, or to be precise, its renamed copy, P, because they join on their common ID column, both in the SQL and in the RA. And there's no need to qualify the ID column in the join with takes, because the natural join removes duplicate column names, and thus there's only one ID at that point in the join process. Second point, the inner sigma on name equal computer science implements the where clause, and it applies directly to the result of the entire 4-table, or actually 5-table join sequence here. Right. The gamma operation lists 3 grouping attributes along with the computed sum. Now this is redundant since ID was the only grouping attribute in the SQL, but doing this does include all 3 attributes in the gamma result, which is needed if we want those as part of the final result. This is the Oracle method we've discussed in earlier lectures for including non-grouping columns translated into RA form. Then, fourth point, the outer sigma applies to the Y result and corresponds to the halving clause, asking if some units is greater than 4. Fifth, the projection operation is needed to remove the product ID attribute from the final outcome. And then finally, sixth, there is no RA translation needed for the distinct keyword. RA results are sets and automatically never have duplicate tuples.